Hello, I'm Matt Helmers at Iowa State University, and I'm going to demonstrate today the nitrogen load estimate calculator from Iowa State University that can be used to estimate nitrate nitrogen load at the field or watershed scale. You can download this tool, this Excel file from the Iowa State University Extension and Outreach Natural Resource Stewardship website under Water Quality, Water Resources, or nitrogen load estimate calculator. And you can download the Excel file. You pull that up, it's going to look like this. It's set up where you can indicate what major land resource area of Iowa you might be looking at. So this is specific to Iowa, but I think it would be illustrative for other parts of the Corn Belt as well, where we have many of these same types of practices and concerns. So what you'd put in there is you could select the major land resource area you're looking at. I'm going to look here at north central Iowa for this example. You can put in your watershed size. I'm going to put in my 1,000-acre watershed with 900 of that in agriculture and 100 in urban. And then of those 900 in ag, we can divide that up kind of with any combination of practices that we want to look at. So kind of my baseline scenario I'm going to look at is 900 acres of a corn soybean rotation with 150 pounds of N per acre. And you'll see here my nitrate loss is about 23.9 pounds per acre, nitrate concentration of about 10.2 milligrams per liter. Now the fun can kind of start. We can look at how the impacts of individual practices or combination of practices might help us. So for example, we could put in that we're going to do cover crops on all 900 acres, and we went from about 10.19 milligrams per liter nitrate concentration at the watershed scale to about 7. So we had about that 30% reduction with the implementation of cover crops. Likewise, we could also look at the impacts of edge of field practices. And one thing we also need to do here is define drainage. And so maybe this watershed, we have 600 of the 900 we estimate to be drained. So we would put that in there. On the baseline doesn't impact our nitrate loss, but does impact maybe where we can implement things like bioreactors and saturated buffers in aggregate. So for example, if we said about half of our area, or about 500 acres, are treated by a wetland, you can see our nitrate loss goes from about 23.9 down to 17, or the concentration 10.19 to 7.3. Likewise, we could also put in, if we're going to treat, we'll say 300 acres with a bioreactor, then our nitrate loss also goes down. You can see here 23.9 versus 20.56. So you can put in those different practices. We could also put in that we're going to have 300 acres of a saturated buffer. And again, we're going to see what that nitrate loss reduction is between the untreated without the saturated buffers in there versus the treated with our saturated buffers. So with this, we can really just adjust what our management practices are on those acres in our watershed and see what the resulting impact is on the estimated nitrate loss in short tons, total loss per acre in pounds per acre, and also the nitrate estimated flow-weighted annual nitrate concentration that we might get from that area. So hopefully this can be a tool you can use to look at the various impacts of different management practices individually or in combination, both in-field and edge-of-field practices, and look at the way that they may impact our nitrate nitrogen that's leaving that watershed area or that field area, depending on the size of the watershed you identify.